is the Nature Conservancy involved in aquaculture? And in fact, we have quite a large strategy now centred on providing food and water sustainably. So we are increasingly involved in agriculture, water resilience and aquatic systems as well, and most certainly fisheries. Within our aquaculture program, let me get this right. Sorry, so just quickly about the presentation, I thought today I would just sort of give a snapshot of what we consider to be regenerative aquaculture or restorative aquaculture, which is what we tend to refer to it as. I'm really keen to talk a bit about why the benefits that we see vary and what some of the drivers are. But I'm also hoping that at the end of the presentation, it would be really wonderful to talk with you all about this as well, some of the things that you've seen and some of the things that you've heard, because this is really where we need a critical mass of information to come forward so that we can better understand exactly how aquaculture systems can be designed to have restorative benefits, but equally what those limitations are. And so what we're now doing is trying to move that forward into a really structured approach about how we can account for variability and improve monitoring. I recognise, this group is a lot about vulnerability, but I did want to emphasise that one of our main interests is this tension between, aquaculture has always been a threat to the environment, has always been perceived as a threat to the environment, but that has been quite a prevailing narrative. And we're potentially overlooking ways that we can design these systems to be more resilient in their own right and to actually bring those benefits of resilience to the broader ecosystem as well. So that's what really excites us about aquaculture. And so what we tend to do in the Nature Conservancy is funnel our science and funnel our work through two primary solutions. One is this restorative aquaculture work that I'm talking about. The other is actually smart growth of fed aquaculture. So we have quite a large science program centred on doing high resolution spatial analyses for aquaculture. We use a typical process of multi-criteria decision analysis, but the strength that we bring is a lot of our high resolution engagement with satellite imagery and methods for processing that. So modelling methods to actually bring together some fairly advanced analyses. So that's our other major emphasis. To us, so restorative aquaculture, regenerative aquaculture, I'll use those terms interchangeably because to us they are synonyms. We talk a lot about regenerative agriculture. We've framed it as restorative aquaculture because we feel that there's a really strong resonance, but also a strong opportunity to enhance the great work that is happening around marine restoration at the moment. We've made very good strides in scaling up marine restoration work over the last few decades, and we feel that this is a way of sort of continuing to enable that work to happen at scale. But what we mean with restorative aquaculture is actually when a commercial or subsistence aquaculture farm or system provides direct ecological benefits to the environment, direct being an important term there, with the potential to generate a net positive environmental outcome. And that net positive outcome might be a point in time, it might be a point well into the future, it might actually be benefits over several different ecosystem services, but it's that potential that's represented here. I also want to highlight at this point in time that this is not a new concept. I really want people to know that we're not trying to claim it by any means as a new concept. Indigenous people have been using regenerative practices for thousands and thousands of years, hundreds of years in many instances, to create this stewardship that is inherent in this process. Also, I think people have been talking a lot about these restorative opportunities through an ecosystem approach to aquaculture, for example. That's been, quite an enduring approach. It's the same ethos and the same idea. And actually, I saw Jenny on the call before, so lots of people have been working on ecosystem services in aquaculture for a long time. This is not new. What we have tried to do, I think, is visualise it and represent that within a commercial setting. And so this pathway is quite an important process to us, or an important structure, because what we're looking at is if we take the negative effects of aquaculture and we put them on a risk management, or into a risk management hierarchy of reducing impacts, mitigating impacts. We then engage with ecologically sustainable development aquaculture, where we can implement practices to achieve those environmental outcomes. That's what then provides us that opportunity to deliver direct environmental benefits and then to potentially accrue benefits over time. But we can't get to this future state of restorative aquaculture if we haven't actually done this foundation that's associated with commercial aquaculture. So I'll move a little bit quicker now. We started our exploration in this process about 8 years ago now, and we started looking at it from an ecosystem services perspective. I still think that's a really useful structure. A lot of people have looked at it in this way as well. The reason I like it is it gets very specific and very systematic about the different things that are happening on an aquaculture farm. So one of the things we did was we said, well, if we've got shellfish ecosystems and shellfish reef restoration, for example, and we have shellfish mariculture, are there actually different services that are provided by each? And in fact, there's probably services that we want to provide through shellfish mariculture, such as food in particular, but also raw materials and other things that we don't want to be providing through shellfish ecosystems. So this was sort of our first way of engaging with this topic. Over the last 8 years, we've done a range of analyses from, desktop review processes to meta-analyses to try and bring together our own evidence base for what's happening here and what that opportunity set is. We found all of these sorts of benefits, which I think are, again, they're fairly well known, they're relatively well published, and most certainly they're widely talked about. These are quite strong anecdotal ecosystem services that we hear a lot of farmers talk about. Providing habitat, for example, obviously filtering water, lots of discussion at the moment about what seaweeds do in a farming system, but also some lesser known ones that I think we really need to just continue sort of going through this conversation, building up lots of data from existing material, but also through field evidence to understand, what is the dynamic role, that sort of multi-directional role of clams, for example, when they're supporting bioturbation. What does that actually mean, and can we therefore design aquaculture to have those benefits? The three major categories that we talk about and that we look across, the first is habitat. What are those habitat benefits that can be provided? We tend not to talk about biodiversity because there's so much more to biodiversity. So we do like to be specific to it's the habitat that's formed by aquaculture. This was our first major piece looking at habitat, a meta-analysis of 65 papers comparing where benefits reported on a farm in comparison to the non-farm reference sites. And across, the major sectors of species, major sectors of shellfish and then seaweeds, there was certainly a multiplier effect. Different strengths associated with those, but there was certainly a strong signal for some added habitat benefit when you've got the structure of aquaculture in the water. The other one is water quality. I think lots of fantastic papers. In fact, I have so much trouble keeping up with the great literature and the great numbers on this particular topic associated with nutrient removal, water filtration rates. There is a lot of material in this space, and I think it's fairly well established now that so long as shellfish systems in particular are being designed with the ecosystem in mind in terms of applying known carrying capacity models and carrying capacity limits, and are representing the seasonal function of an ecosystem or an embayment, you can actually get relatively good benefits to water quality. And so those will be improvements in turbidity and improvements in water clarity and light attenuation for bottom habitats, and it will be the nutrient uptake as well. Interestingly, there's lots of some really interesting work about the role of denitrification in aquaculture too, most certainly closely related with on-bottom shellfish aquaculture. This paper didn't find a strong signal for that. It found that the bulk of the benefit to water quality and nutrient uptake was through bioextraction. So assimilation of the nutrients within the shellfish and seaweed itself, and then when they're removed, you can take those out. That just opens up a really interesting question then about, well, where does it go? And so one of the things that we're excited to have other people look into, I think, is that opportunity that's associated with the product. It can be a very nutritious product, but also can be quite an intentional product to direct nutrients and other materials. And then the third area that we look at is certainly climate resilience. We have done a little bit of work recently around seaweeds that I'll talk about in a moment, but climate resilience to us is a much bigger picture. So we're thinking about the role of farms in the water. How can they potentially be used to enhance blue carbon ecosystems, for example? So if shellfish are having this strong water filtration action, can that actually be deployed to intentionally support seagrasses that are on a declining trajectory? We've been looking into product uses as well, mostly around seaweeds. So for us, we're actually really excited about the opportunity for seaweeds on land, because it does start to get into this win-win scenario. So if we've got seaweeds that are farmed in the water and they're taking up nutrients, can we really take that a step further and grow some products that can have a wonderful outcome on the land as well? And so we're going to be digging into biostimulants over the next year or two to see if we can make a bit of a difference there, I think, about trying to increase the market appetite for biostimulants. What we've released recently is actually a tool, and I just wanted to flag this with people in case it's of use. This tool was developed by SciTech Consulting. They're actually based out of Vancouver, and they did a regional model for Canada, and we asked them to scale that up to come up with basically a model that could be used generically across large marine ecosystems. This tool is a calculator, and it enables people to go in and calculate if they're farming a particular area of seaweed in a particular species, and then they're directing 100% of that to biostimulants, or 10% of that to biostimulants and 20% to food. It helps apportion out the emissions that are released from farming with some sequestration rates associated with those particular products, and then comes out with the potential overall CO2 impact at the end of it. So a bit of a fun tool. It's not perfect, but we're keen for people to start thinking about these things and to give us feedback about how we can then fold in more data to continue to improve them. We've also been doing a little bit of work on marine finfish. It's not as big a portfolio for us. We do tend to focus on bivalves and seaweeds because of their inherent benefits. But we are interested in making sure that we're not, making assumptions about any particular sectors as well. So might have been crazy, but it's also been very interesting. We did do an initial analysis, and I'm keen to continue on with this, to think really clinically about how marine finfish farms could potentially have biodiversity benefits. The obvious answer is that they can't and that they don't. But again, if we come at it from that perspective of what are the ecological processes and the ecosystem services at play here, it provides that framework to break it down and be very systematic about all the different things that are happening on the farm. And so that's what this process was really about. And in fact, when we look at it from that perspective, we do see that there could be the potential, for example, to think about if wild fish are associating with a net pen, can we be mindful of of the fact that they are associating and how they're associating, why they associated with that farm, and direct that fish biomass into a more proactive opportunity for conservation or resilience. So it's just trying to provide a bit of a bigger picture to it. I'm not sure, where we will take the marine finfish work in the next year or two, but I do think this warrants more attention for sure. So just to finish off, one of the things that has come, finish off this section, sorry, one of the things that's really come out is that, as you would assume, this is a very dynamic space. There's lots of different things at play, and so we try and keep that in mind, that this is a lot. It is that the benefits that are provided are an interplay between local environmental conditions, the gear that's used, the species that are farmed, and the farm management practices that are applied. There's also a very strong interaction with how it's viewed by the public, how it's viewed by regulators, and so these systems are an ecosystem in themselves. And so we're now trying to go deeper into each of these particular areas to get a much more nuanced and I think also evidence-based understanding about what's going on here. So that brings me to the second section. So what we've done recently is fund some research through the University of New England and the University of Auckland. It's been a 4-year study that's just wrapped up this year. And what we were doing was responding to a literature review that we did quite a few years ago now, where we identified that actually habitat was a perceived benefit for aquaculture, but there was comparatively little information actually available through the review process that we did on this interaction. And in fact, there was no information on temperate seaweed farms and how they might be providing habitat. There was only information on tropical seaweeds. And so we picked these two geographies, Aotearoa and the Gulf of Maine in the USA, and we worked with Carrie Byron at the University of New England and Andrew Jeffs at the University of Auckland to develop a comparative sampling method. The aims of this particular project were to use that comparative method to identify and quantify the habitat benefits of kelp and kelp mussel co-culture. For fish and invertebrates. And we sort of thought that we might be able to move that through to this understanding about some of those general ecological principles that might apply in these systems, all else being equal. Very similar species, same method of farming. So are there some general principles that can be applied? The methods that we used were GoPro cameras. We did do some eDNA sampling as well. Not a lot of coherence between the eDNA and the GoPros. They picked up different things at different times. And then invertebrate collectors hung within the kelp farm and the kelp mussel farms as well. And what was really interesting about, sorry, I think I skipped over. What was really interesting about this particular project was contrary to our hypothesis, where we thought that both systems would be providing a habitat benefit. In fact, there was no discernible effect found in the Gulf of Maine. There was no adverse effect, but there was no positive signal either. And in fact, there was very few fish, and they were largely indifferent to the presence of the seaweed farm. In contrast, the Hauraki Gulf had a very strong signal for a habitat benefit, and I'll go into that one in a little bit more detail in a minute. But lots of strong association of fish and invertebrates in Aotearoa, but not in the Gulf of Maine. But then when we think about that scenario of the Gulf of Maine where you have seasonal farming of seaweed, we can actually refer to that as a neutral biodiversity impact, and that neutral impact is actually a good thing. The reality is they're farming seaweed in winter, so it's quite cold. There are fewer seasonal fish in the Gulf, and they're just not present there at the same time that the kelp farm is. But because they're required in the Gulf of Maine to remove the seaweed, if they were having a strong effect on biodiversity, if they were providing a lot of habitat, that actually would be quite a discussion to have. So how are we going to manage these seaweed farms every time we take the biomass out of the water? So a really interesting insight and a fantastic process to go through to come to that sort of realization. Pardon me. But what came out through this research is that amongst all of the potential drivers, the local environmental conditions most certainly seem to be driving the bulk of the effects that are observed, and that is largely associated with what's the nature of that particular local ecosystem, the fish that are present, what are their habitat needs, for example. What we found in New Zealand, pardon me, was that there were a large number of fish associated with both kelp and kelp mussel farms. And in fact, some fish were recruiting into these farms as well. So we weren't just getting an association, we were getting recruitment of particular fish species into the area. Now, Andrew Jeffs and his colleague Lucy Underwood have a great set of papers. I think Lucy has another one coming through at the moment. So I've listed these in the presentation for you all to use if you would like to do so. But certainly very strong signal and a great contrast to the Gulf of Maine. In this particular paper here, they looked at the gut contents of snapper and did quite a detailed analysis of a small subset of snapper. And they found that the snapper that were foraging in the kelp and kelp mussel farms were actually eating a more diverse diet. So they had access to a broader range of dietary requirements and things that they could eat, and therefore they had a much more diverse diet. What they went on to do was to also show that the quality of the diet for the snapper was better. And so this graph here is mean lipid content for snapper foraging within a mussel farm as opposed to a non-farm reference site, and they found that the lipid content was significantly higher. They found that snapper were working with a reduced foraging effort in the farms, and they had a more diverse diet, and so they also had a high nutritional diet within those farms as well. So their last paper on this particular topic was a fantastic one about basically fat snapper. So feasting in mussel farms fattens up the snapper. What they've shown too is that because in the Hauraki Gulf, there are some significant strains around habitat decline for snapper in other areas, is that the snapper are actually starting to display milky flesh syndrome. So they don't have all of those nutritional requirements coming through into the flesh. And so they're basically skinny fish with a really poor flesh quality. So this is just the link of the resources. We also have posted all of this material onto TNC's Aquaculture Science Hub, so just aquaculturescience.org. We have a range of resource papers and everything that we publish, from reports to infographics to videos to published papers, is all available on this website as well. But that's been a great project for us. Not entirely what we expected when we set out to do the work, but it has been eye-opening in multiple ways. And just to reiterate, what hit home was that these benefits that ecosystem services appear to be so context dependent that while I think we can start to say, here are some general effects that might occur, we all need to be really mindful that those effects are they're very much driven by the state of the environment, the challenges and the stresses from climate change, land-based runoff, the status of fish stocks. We need to think holistically to build up a picture of what aquaculture is actually doing in our local area. And so that brings me to the last part of the presentation is how do we do that? How do we account for a highly dynamic sort of, framing, a highly dynamic context, but do so in a way that we can continue to learn from each other. And, one of the things that I always want people to know is we need more information about how these services are working so that we can make sure that we're moving aquaculture through from that state that I showed at the start, where we have fully eliminated the negative effects and we are designing systems to have these multiple benefits to people on the planet. And so we've sort of now, the last 24 months, been engaging in a process with industry, researchers and government to try and understand how can we do that? What's the best way that we can actually approach this complexity and this need for some consistency in monitoring and evaluation. We did some phase 1 guidance, some sort of preliminary guidance through a document of the Global Principles of Restorative Aquaculture, where we basically tried to put some shape to what people were saying is a very academic, a very nebulous sort of concept, quite likely there, but how do you actually start to put some structure around that? And so it was, putting words to paper. I'm an advocate of having many definitions. I think that plurality is useful because it means different things to different people, but we put some words to paper to try and give it some shape. 6 global principles for restorative aquaculture as well. And then we developed a couple of roadmaps to say, here are some questions you can ask to start to understand whether you are potentially having a restorative benefit or not. Our phase 2 guidance then scaled that up further to provide a structured monitoring, evaluation and learning framework. And so we're viewing that as a best practice approach to monitoring for these benefits in the environment. And as I said, we included industry, research and government as well to try and shape that, because whatever we recommend has to be practical and it has to be achievable for farmers. And then we described a set of goals, objectives and some indicators that people could go ahead and actually monitor on their farm to see what was happening and what benefits they might be providing. It can be adopted as is, but it can also be adapted for a local context. And so we're really advocating for people just to see this as a foundation, a genuine framework, something that they can use, that they can apply, but they could also, add in further objectives if they think they need to do so, or make some variations to the objectives as well. That's purely a starting point. The framework is not intended to replace any standard environmental monitoring procedures, and it's not intended to be a certification scheme either. Carrying our focus around the habitat benefits, we describe these, describe the objectives across the 4 benefit categories that I've been talking about: habitat, water quality, climate change, food resources and livelihood. I think there's a lot more that could be built out in these particular sections. But we also didn't want to be overwhelming. We want industry and government to try and use the framework and to do so in partnership with researchers so that they actually have something that's actionable. The framework uses a strategy-based approach. As I said, the goals, objectives, indicators and monitoring methods. And this approach is validated through the Society for Ecosystem Restoration. It's very well established for restoration projects. And so we thought that was a really good approach to use. And it seems to be quite intuitive for people once they see it laid out. And just briefly, we've also provided some guidance on how to measure, monitoring methods themselves, but then how to actually apply those. Some are still going to be very complex for farmers to do, but we've been quite conscious about trying to pick methods that farmers can actually use as well, things that are easy for them to apply, and what might that tell them. And so this is basically the back of the document. We have, for the 3 different sectors of mollusks and echinoderms, seaweed and marine finfish, we have 4 tables, 1 each, for those benefit categories. We describe a goal, those objectives, the indicators, and then we're really hoping that what people can do is to come together to start consistently collecting data on this particular topic. We think it's a really big opportunity. What we're now doing at the Nature Conservancy is describing aquaculture as having the potential to be the world's leading regenerative food system. And so we believe that we can actually action a lot of this learning and a lot of these practices to really drive a positive step forward in the industry. That's obviously going to be very hard to do, but we're comfortable with the evidence base that's there, and we're comfortable with how well we've been able to systematically work through all of these processes and dynamics. And I think that if we keep at it, then we most certainly see a really wonderful opportunity to see aquaculture become far more resilient and to also improve the resilience of ecosystems worldwide. So I'll leave it there. As I said, partway through, I would be really excited to obviously answer questions, but to hear examples and ideas and thoughts that you all might have come across as well.
Thank you very much, Heidi. That was an excellent presentation. I think touched on a lot of